In the previous video, we saw how to add two algebraic fractions if they have the same denominator. Now, if they do not have the same denominator, then the process is a little more complicated, but just as with number fractions, we must start by getting a common denominator. Okay, the second step, once we find the common denominator, is to write equivalent fractions. And then finally, we will add those equivalent fractions. So for example, if we need to add 3x over 10 plus 2x over 15, we first need to decide what the denominator is going to be. And our denominator in this case, I think it's easy to see, is going to be 30, right? This is the smallest number that both of these numbers will divide. 3 times 10 is 30, and 2 times 15 is 30. Next, we need equivalent fractions for our algebraic fractions, so we need to write 3x over 10. And then we're going to end up with our denominator 30 there. And then we have to ask ourselves, what do we need to do with this fraction so that the denominator becomes 30? And it's clear, I think, that we need to multiply by 3 in order to get to 30 from 10. Now if we multiply on the bottom by 3, we must multiply on the top by 3. So our equivalent fraction here is 9x over 30. And then we have to do the same thing for the other fraction. 2x over 15. And that's going to end up with a denominator of 30. So now, how am I going to get from 15 to 30? Well, I need to multiply by 2, don't I? Okay, so that gives me an equivalent fraction of 4x over 30. So then finally, I can do the addition. 3x over 10 plus 2x over 15 is equivalent to 9x over 30 plus 4x over 30. Now I do have a common denominator, so I can just add those numerators and get my answer. 13x over 30. Okay, and it is sketched out here in the notes. I went into a little more detail just now. Okay, let's do one more example. Now we have to add 5 over 2x plus 2 over 3x. Okay, so what is going to be our denominator this time that we need? Well, the least common denominator that we need is the least common multiple of these two monomials, 2x and 3x. We've already seen how to do that. We need to write down a monomial that contains all of the factors present in both of these monomials, namely 2 times 3 times x, or 6x. So that's going to be our denominator. And then we need to write equivalent fractions. 5 over 2x. This is going to be equivalent to a fraction with 6x as the denominator. And clearly what we need to multiply by here is a 3. And that gives us 15 over 6x. Okay, the other one we have 2 over 3x. And that's going to be equivalent again to some fraction with 6x as a denominator. This time we need to multiply by 2, don't we? And that'll give us 4 over 6x. So now our original problem, 5 over 2x plus 2 over 3x, equivalent to 15 over 6x plus 4 over 6x. Now we do have fractions with a common denominator, so all we have to do is add the numerators, and we get our answer, 19 over 6x. And again, I have sketched out the solution here in the notes.